Now, plastoid scales. These are going to be hard tooth-like scales made of dentine and enamel in the skin of sharks and rays. We also got our collagenous skeleton. This is going to be a skeleton made of cartilage instead of bone, providing flexibility and strength in chondrithesis. So it's chondrich thighs. Now we also have tooth whorls. These are going to be multiple rows of teeth in the jaws of the same chondrithesis, enabling continuous replacement. Now we have a few unique jaw attachments. Distinct, the way the jaws connect to the skull allows for more powerful biting and feeding mechanisms. That's with, the chondrites. That's all the jaw does. We also have pelvic claspers. These are modified pelvic fins in male sharks used for internal fertilization, unique to chondritis or whatever they're called. We also have a lipid-filled liver filled with lipids to maintain neutral buoyancy, aiding in efficient swimming. Just keep that in mind that their liver is filled with fat, and that's how they do efficient swimming. We also have plastoid scale evolution. The evolution developed of teeth from external plastoid scales associated with the oral region. So, plastoid scale evolution is the evolutionary development of teeth from external plastoid scales associated with the oral region. Now we have a few jaw suspension types. These are different ways the upper jaw is connected to the skull, including feeding and hunting strategies. We are at the Neosalachi projecting rotisium. This is an extended snout or nose in some modern sharks, serving sensory and feeding functions. Remember, the Neosalachi projecting rotisium is the extended snout or nose in some modern sharks, serving as sensory and feeding functions. We also have the Neosalachi tapetum lucidum. So Neosalachi tapetum lucidum. This is going to be a reflective layer behind the retina for enhanced vision in low light, aiding in hunting and navigation. We also have the Neosalachi electroreception. Neosalachi electroreception is going to be the ability to detect electrical fields produced by other organisms, assisting in locating prey and navigation. Repeat, the Neosalachi electroreception is going to be the ability to detect electrical fields produced by other organisms, assisting in locating prey and navigation. Now, Neosalachi biofluorescence. This is going to be the ability to absorb light and re-emit it as a different color, possibly used for communication and camouflage. Repeat, the Neosalachi biofluorescence. Neosalachi biofluorescence is going to be the ability to absorb light and re-emit it as a different color, possibly used for communication and or camouflage. Now our Neosalachi endothermal heterothermy. Repeat, Neosalachi endothermal heterothermy. This is going to be the ability to regulate body temperature independently of the environment. This is going to maintain a metabolic activity in diverse environments. So the endothermal heterothermy is going to be the one that they can regulate body temperature, like tuna. Now, the Neosalachi heteroserial traits, these are going to be a few. We got tail with unequal lobes. The upper lobe being larger, aiding in lift and maneuverability during swimming. Repeat, the heteroserial tails are going to have two unequal lobes, the upper lobe being larger, aiding in lift and maneuverability during swimming. Lastly, we have the reproductive styles of the Neosalachi. This is going to be different methods of reproduction observed in modern sharks, influence population dynamics and survival strategies. So those are going to be live and not living births.